Okay, I created a sparse session object. Then I'll create this employee data set. So they're saying it is going to be deprecated. This creating a data frame with the list of dictionary object. They are asking to use the instead of uh, dictionaries, asking you to the row object, which also we discussed yesterday. So employee record is there. Data set is there. Like data frame is ready. Now let's create the department data frame, and we'll try to see this. Dot print schema will help you to see the estimate. I'll just save this. Okay, we'll go back here. So if you want to see the schema of your data frame, you can use this print schema function. I'll run this. So you can actually go on if you want to only few columns you want to see, then you can just remove these columns. You can run this. Right. So select function is basically to act as a select clause in your SQL query. And then if you want to do union operations, basically union operation, you need a similar structure of data frame. So what I'm going to do is I just create a data frame, new data frame with take the copy from the another data frame. So just df1 equal to department df. So you will get another data frame. So you can actually perform union operation. So union is basically one function. The first data frame, union of second data frame, which will give the union data frame, which is basically this records. Unless your columns structure is same, so it is going to do the union. And if you want to perform distinct, right? So you can use a distinct keyword. So you can do the distinct at column level or entire data frame level also. So if you want to do the this is at a data frame level. So if you look at here, this data frame which we created the union data frame as a duplicate rows, right? So department ID 1 and name is finance. So it's repeating here. So if you want to take a distinct rows from here, you can use the data frame dot distinct function. If you call it, it's going to return only the distinct data frame. If you want to do, okay, let's run this. I think I have not run that one. Okay, so this is data frame level. If you want to do column level, you just select that column. So this is the union data frame dot select of department name, and you can apply the distinct function. So it is going to give that all this department names, distinct unique data frame, unique data frame department names from this data frame. This is also fine. Now finally, this is the before we do the join operation. So this is the employee data set, and this is the department data set. So we have a department range from 1 to 5. Okay. So for the sake of uh, all the to get the result for all the joint types. I made the employee records in such a way that it will all the joint type works. So some of the data, departments not created. Okay, so but still I used it just to get the right outer join. Okay, so that's so you have a department 1, 2, 3, 4, 5 is not there, and 6 and 7 was extract is there. Okay. Now let's do the inner join. Okay. So when you say data frame, which is example, the first data frame is an employee record, right? Join, you have to use the join function, and then the second data frame, and you have to pass the column, like the join column is a department ID in this case. Okay, so and then we are going to we are going to give the so this will give you the join data frame. Employee dot join of department data frame, and if you provide the join columns, it is going to give the joined data frame. So it lack. So if you don't provide uh, this is so if you don't provide the join type here, you can provide the join type. If you don't provide the join type, it is default. It is going to consider as an inner join. That's why it is all our whichever department ID is matching your employee record, it is giving. So it is going to be returning you the 8 rows. And then now you can once you have then this is just to uh, join data frame, and you given the list of columns to get it, and employee IDs are not ordered here. If you want to do order, you can use the order by function. So this is your join. It is going to give you the join data frame, and then you can apply the order by on particular column, and then show the data frame. Let me run this with DataFrame. Okay. Alert. And run this join. This is the join data frame, and let me run this with order by. The employee records are ordered. The next one is okay. So here the select class, I just provided the column list, right? So these are the list of columns which I'm providing. So other way to read your columns is in the select class you can say data frame of the employee, and in the bracket, in the square bracket, you can put star. So it's going to give the all the columns in the data frame 1, which is employee records, and you just select class how you want to represent, and all the columns from the data frame 2, which is the department data frame. It's the same result. Only thing is you need you're providing the select class. You're giving differently to fetch your columns. This is now I'm just going to inner join is the default join. Now I'm going to provide the left outer join. So for that you need to pass your join type. So for the join method, you need a data frame. First, you need to pass a data frame and then the join. So you can provide if you provide a department ID, it is going to do the join. Going to by default, it will prepare the join condition with the department ID, or you can provide this join condition also here like this. From employee ID, sorry, from employee table, department ID is one join column, and from the second data frame, this is the column to do the join, and you passing the join type. So it's going to do the left outer join. So all the records from the so all the 10 employee records are there, okay, and whichever is the matching based on the department ID, those information is taken brought from the department table. But there are few employees which does not have uh, employee records, which are those, like if you look at the uh, Ajay and Vasant, uh, Ajay and Vasant, they're having department ID as 6 and 7, which does not have a department. So that's why it is showing as a null here. Okay, so I hope this is fine. It's typical your RDBMS functionality, but only thing is how do you are expressing in your data frame function operation is one, it's going to be different. Similarly, right outer join, you can pass the join type as right underscore outer. So since we don't have, so if you look at here, from the right side, which is right table is a department table, right? So we have 5 departments. So it's getting all the 5 departments. Okay, and we have how many? 8 employee records are there. Okay, because those are the employees who have the department IDs available in the department table. Only this training department is not mapped to any other employees, so that's why it's showing null here. And when it comes to full outer join, it's going to give you this 10 records where null for the departments, sorry, employees which does not have a departments, which is there in the department table. And similarly, one more row which having the extra department and does not map to any employee. So I hope this is syntax wise, this is the syntax, but functionality wise is same as like how the SQL joins works. Any doubt in this? All right. So
No, no.
this is the how to perform a join operation in a data frame using data frame. Now we'll go back to one more thing. We'll open this aggregate operations. Okay, we'll go by one by one. So I'm using this invoice CSV. Okay. So I'll just show you the records. Yes. So this is the invoice data set, which has columns like invoice number and stock code, uh, basically the product or item code, product or item code, and description of the product and the quantity, how many quantity it is purchased, what is the invoice date, and the unit price of the product, and customer ID who purchased, and the country on which the purchase is happened. These are the columns it has. Okay, now with this we'll try some of the aggregate function which we can apply on this data set. So first thing is we are reading the CSV file. Okay, so run this. So if you actually can, what you can do is there are multiple way you can actually import your functions. One is this way, like from PySpark.sql.function import star. So it is going to import all the functions from the functions from the functions package, or else you can import this way also, like from import PySpark.sql import functions this package as a, like you can create alias for these functions, then you can access f dot that particular function name. That way also you can do use it. So we just creating a functions alias for this functions package, and you can access the methods using a f dot. Okay, now the next step is to create a invoice data frame by reading the CSV file. So there are multiple ways you can create. Okay, so you can use Spark session object dot read dot CSV, or we can also do format of pass the particular file format you want to pass. This is also one way to create your CSV file. Okay, so okay, let's run this. Sorry for the background noise. So database frame is created. Let me just show you this the content of data frame. So these are the data frame is looking like. So how many record it has? So it has close to 5,41,909 records are there. Okay. Now we want to, if you want to perform aggregate operation, okay, if you want to apply the aggregate functions, so basically you can apply. So basically function dot, so if you want to find a count, f dot count star of I just count star of you can just give alias name as record counts, not the count. I'll say records count.
Pari, one question here.
Yeah.
This here also you are spilling to different line, but you are not giving that backslash.
Which one?
No, normally you give a backslash, right? Whenever you
Uh-huh.
go to the next line. But here you are not giving.
That's I think depends upon the ID.
Okay. So in
Maybe.
Jupyter it's not required.
Yeah, I guess so.
Okay.
So this is, I'm just creating a records count column using a count function. So I'm accessing count function from that alias I created for functions, and trying to find out the total quantity, and trying to find out the average unit price of the product, and also just trying to find out basically here uh, distinct invoice number. Okay, so why I'm finding distinct invoice number? So if you look at the data, there are if you have an invoice, there might be a multiple product purchase with that invoice, right? So it is represented. See here, one invoice number has multiple product purchased. So all are in two different records. So we have to find out distinct invoice number. So that's why I'm using a count distinct function, and I'm passing the column. So this is going to run. These are the results it is getting. The average unit price of the product is almost $4.6. And if you look at here, there is here I'm using a select. In the select class, I am actually putting all these functions. I can also express, there is a one more function called select expr. So instead of using a function, I can put that like instead of using as a data frame function, I can write a like SQL statement. So count star or count one as alias, right? So here you are using alias function. You can just, here it's more of expressing a SQL statement like this. So anyway, these methods will go and pick it from that same um, SQL functions. Yes, I yesterday I told you for running, see, whenever you perform data frame operations or using a SQL statement, it is going to do the same behind the scene. It is going to use the same SQL optimizer and parser, everything, SQL engine, everything is same. Only thing is that you express your code in different ways. That's what we discussed yesterday. So it is also use it will go and use the same count method. Right? So I'll run this. Okay. So if you want to make it in a proper SQL statement, you have to register this as a temporary table or temp view. There is a function called in a data frame. You have a function called a create or replace temp view, and then you can give the table name as view name as sales, and then you can write your code. So Spark session dot SQL of write your SQL query. So once this is the table, so you can write a SQL statement like how you do on a other RDBMS. So select country, respective columns, and what is the aggregate function you want to do. So I'm just doing the total quantity, and I'm trying to find out also total invoice value, which is quantity into unit price. I'm just summing up all this and making a round off with the 2 decimal, I guess. Yeah, 2 decimal points. So this is the way you express your logic in a SQL interface. The above one we saw data frame operation. This is SQL interface.
Which SQL it takes, Pari? Is it any specific vendor, or it has its own syntaxes?
It has its own syntaxes,
Okay.
but
Do
it
we need
is
to put in triple double quotes?
no.
That
You can you can no, you can put it in double quote also.
double quote also fine, right? Yeah. Okay, I got
Unless
it.
you don't have double quote inside, you can use it. Yes.
Oh, okay, okay, okay. Single quote also you can give, right?
Yeah.
lowercase?
Yes, yes, you can
Okay.
use. Yeah, maybe it's, put this because of the maybe multiple lines, I guess.
Okay. Okay. Oh, okay.
And okay, so here, if you want to apply a group by, okay, so which we saw discuss. Whenever you want to group by your data and then apply aggregate function, you have to use a group by function and pass your columns. And then on the grouped data, you need to use this ag function and then supply your aggregate functions. So what we are doing is group by country and invoice, because the multiple invoice or like multiple entry for single invoice also. So we are actually doing that way, grouping by a combination of country and invoice. And in the ag function, you pass first aggregate function as total quantity, which is a sum of quantity, and getting a column name as new column name as or maybe renaming the column as total quantity. And then it gives you the next is finding the invoice value, which is quantity price unit price. uh, so this one we can use this since the sum is going to take only one columns, right? So it is going to, you can use this function express function express.
Direct without expression we cannot write.
You have to pass as a column.
But here
So
you passed. Okay.
here
SSC.
select expression is there.
Uh-huh. No, but we are giving in bracket, right?
No, actually this is going to, sum is going to get one column. I think only one column, right?
If you put in bracket, that will become one column, right? Without.
Uh, See, that's what that it will not. Okay, let's try that. Wait, let me run this, and also will, I will remove this. And just, so it is no, it will not. What it says is this statement is act
Uh,
as a column.
I think
So
individually you can give.
yeah, individual
Okay.
columns you can give.
Okay. Okay. Within bracket, individual column. I can, yeah, yeah,
Yes,
yeah. I think it is expression. Both the columns it is.
yeah, it's considered as a one column only. And then this is,
So in real time, Spark SQL is used more, or
sorry.
I mean the real time
Uh-huh.
while working, is it being used more?
Yes, yes. So all
Spark
your
SQL.
see all your data warehousing projects is more of Spark SQL only.
The transformation and SQL, right? These two.
Yeah, correct.
Transformations. Okay.
Transformation in that sense, so obviously the see here even
And,
this is also transformation only. Okay, so
yeah, yeah. Okay, okay.
probably this is transformation, right? So
Yeah, yeah.
this is
Fine.
a data frame transformation.
Okay.
So in your Spark SQL, when you go to any data warehousing project, it's more of the data frame operation or SQL operations, and so that's where it all your, I think uh, Prakash also saying. So when the people start building the enterprise data warehouse, So they migrate from all your ETL tool to PySpark. So using all this
Okay.
Spark SQL only.
Okay. Previously, I was working on Informatica for some time.
Uh,
I think those are getting replaced by these SQL tools.
correct. Okay, and you can find out this way also. So
Oh, like this is okay.
this will you will apply on the here. So you actually whatever code we written here uh,
Verse number.
in this, did I remove this?
But DataFrame. No, yeah.
See here, what we say this portion of right. You can actually take this portion and assign it to one variable, and you can use that variable in the next query. That's it's kind of uh, um, writing your logic and storing it. This is basically kind of one logic, right? So, and you are making as assigning to one variable, and when that variable you're using in Hag. So I can just
Okay.
copy paste this portion into this, it will work.
Okay. Yeah, yeah.
Just making it as a variable, and I'm just using it. And okay, so so there are multiple, as I see, we saw till now all this group by, ag, order by, and join, union, distinct, right? Similarly, there is a one more transformation or function called with column. So I have a data frame. If I want to create a new column on the data frame, then I would need to use a with column. Okay, so with column, you have to pass the new column which you are going to create and the logic on which your new column is going to be. Mostly, the with column is derived from the existing data frame. If you're actually, if your with column value is not derived from the same data frame, you can pass only literals. Okay, so I cannot, uh, uh, I cannot actually create a new column with other data
Different
frame.
data. Okay.
So only it can be derived from the same data frame, or it will be literal like constant values. Like it can be a simple string value or integer value or float value. And where function is there or transformation is there. So this is very similar to your where class in your RDBMS. So you pass your condition. And group by we know, ag we know. This one I did not run. Okay, so this is the result of this transformation. And if you see here, so in RDD, if you want to know the number of partitions in RDD, we use RDD, that particular RDD dot get num partitions. Similarly, in data frame also, data frame is nothing but internally it is RDD only. Okay, so data frame dot RDD dot get num partition will give you the number of partition in your RDD, sorry, in your data frame. So it has 200 partitions. Okay, what happens is, see, if you look at the initial data frame, okay, so which is invoice, right? If I put this dot RDD dot get new partitions. So initially it has only 2 partitions. Since we read from the file, so it's a local Linux file system, so it has 2 partitions. But when you apply this SQL operation, both DataFrame or DataFrame operation or Spark SQL operation, it is going to create you the 200 partitions by default. Okay, so there is a shuffle partition property which is defined in a Spark. So it is going to create 200 partitions. That's what they claim, that is ideal partitions for a shuffle. So we can modify that property using, if you want to modify, you can modify that value also. And then we discussed about coalesce in RDD, right? So if you want to reduce the number of partitions, here it is, we saw a 2 partition. So if you want to make it a single partition, you can use the DataFrame.coalesce of 1 and then write it into the particular uh, uh, format you want to write. So you can, if you can write in a CSV, you can write as a JSON file, or you can write it as Spark or any other format. So write is how we read is basically data frame, sorry, Spark session object dot read dot particular file format you give. Write is more of data frame dot write. So but we do this transformation. So this transformation dot write of, and you can put this directly JSON also, write as directly JSON, or you can use format of JSON, and the mode is overwrite. If you have that location, if the particular file is there, you will overwrite, and then save as the give the path of your uh, where you want to write your data frame value. Okay, so probably with this I will close up today's. Tomorrow I will have a few more. There are other functions we can apply on Spark SQL, like analytics functions and Windows functions. Those are very important. I will cover it on Monday.
Sure.
Okay then. See you on Monday. Bye.